first webinar for 2015. We are continuing our Next Generation Construction Techniques series, this time on advanced residential water heating. My name is Shannon Todd, and I'm with TRC Energy Services, implementing both California multifamily new homes and California advanced homes. We're going to start the presentation off with a brief introduction of the programs, and then I'll hand it over to our presenters today. So next slide. Great. So most of you are familiar with GoToWebinar. This is our software that we use for presenting all of the webinars that we have done so far. And we will be recording this webinar and also distributing the slide deck. So all of you who are attending, just stay tuned for the recording. And we're actually posting these all on our YouTube site now, which is pretty cool. So you'll actually be able to access all of our historic presentations as well. And we will take questions. I think we'll try to save most questions for the end of the presentation, but of course as they come up, feel free to enter them in the questions bar. We won't be taking audio questions unless perhaps we'll stay on at the end and take some that way. But feel free to type questions as they come to your mind. And if a lot seem to pile up, we may take a break and answer some mid-presentation. Next slide. So California Multifamily New Homes and California Advanced Homes Program are PG&E sponsored ratepayer funded programs. TRC Energy Services runs those programs on behalf of PG&E, so you can thank them for all of the incentives that you guys are receiving as part of participating in the programs, as well as the design assistance. Next slide. So a little more detail on the programs. If you're not familiar, CAHP, California Advanced Homes Program, is the single-family program, so it's residential new construction. California Multifamily New Homes is the multifamily counterpart. And both programs will have a 2015 program. CAHP is already open, and CMFNH will be taking applications soon. So if you would like to learn more about the programs, or if you have a particular project in mind, we'll have our contact information at the end of this presentation. So please feel free to get in touch with us. Both programs are only taking 2013 Title 24 code projects, so keep that in mind. We talked a little bit about the funding source and the goals of the programs. In the short term, these programs serve to help prepare folks for code changes. We've talked a lot about high performance attics and high R-value walls. In the long term, the goal is, of course, zero net energy. So we'll probably be talking about that a little bit during this presentation. I think we're ready for the next slide. And just an upcoming event to keep in mind, this year is the first ever California Building and HERS Professional Conference, which is a track of the ResNet conference that's happening in San Diego. So you can still register for that conference, and we have a lot of folks, including Matt Christie and I believe Scott Kessler, also presenting at this conference. So please feel free to stop by. I think CAHP is also going to be present tabling at the event. So we would love to see you in person instead of just as on a webinar. That's always great. So we welcome you to come visit us. Next slide. Okay, so I think we're ready to move on to the agenda, and I'd like to introduce our main presenter, Mark Hoechley, today. He'll be presenting on these topics, water heating, California, Title 24, and water heating, field performance. And then the last section is specific to the California Advanced Homes Program. Because this is a webinar featuring residential water heating, it's a little bit more, well, quite a bit more relevant to CAHP, although multifamily housing developers that are working on townhomes with individual water heating systems may also benefit, or any other multifamily with individual water heating systems. So I'm going to introduce Mark and then hand it over to him. So Mark is an engineering director at Davis Energy Group. Over the past 30 years, Mark has specialized in systems monitoring and technology evaluations for a wide range of utility and government clients. He has been involved in California Title 24 code enhancement activities, including single-family water heating, and the recent integration of mechanical ventilation cooling into the 2013 code. Mark has a BS in Civil and Environmental Engineering from Cornell University and an MS from UC Davis, and is a licensed mechanical engineer in California. So we're very much appreciative of Mark for joining us today and assembling this presentation, and I'll hand it over to him now. Thanks, Mark.
Thanks, Shannon. Excited to be here today with you and share some of the work and provide an understanding of how water heating fits into the whole compliance picture in California. Davis Energy Group is an energy consultancy that's been around for 30+ years, and as Shannon indicated in the intro, works within Title 24 as well as research activities, exploring new technologies and so forth. So today, as far as an overview, what we're going to cover is to look at, how significant an end-use load is water heating in California households. So look at some data there, and then explore on a superficial level how the water heating modeling works within Title 24, and what the impact of current available and advanced technologies are within the existing Title 24 framework. And then we'll talk a little bit about some of the field work that we've been involved with in recent years that looks at some of the new emerging technologies and actually gets into the field performance of these systems, and kind of in the California environment, which when you look on a national basis, you're dealing with different loads and different climate impacts. So there's some interesting findings there. So on a high level, if we're looking statewide, the California Energy Commission puts out this residential appliance saturation survey on roughly 5-year intervals, where they do detailed utility bill evaluations of tens of thousands of households, and glean data from the bills and what features people have installed, and they gain an understanding of energy end use and appliance saturations and so forth. So one of the interesting findings from the most recent study is that now in California, gas water heating is a larger fraction of the total household gas consumption, excuse me, gas consumption than space heating. And this is primarily due to, over the past 10, 15 years, much of Title 24 has addressed improved building envelopes and improving envelope air tightness and duct efficiency and all that. So space heating loads are on a downward trend, and water heating is roughly staying stable over the recent years. So water heating is a big part of the energy picture in California that we're looking to address. This schematic and the numbers shown here are more for informational purposes, and what we're trying to convey here is for a standard atmospheric gas water heater, which is in the vast majority of California homes, the center flue water heater designed with a continuously burning pilot light. There are 4 main energy flows that define the total energy input, or what's consumed at the gas meter. So on the right you see the end use, and this is actually what's coming out of the fixtures and could be considered the useful energy used at sinks and showers, tubs, appliances, and so forth. To deliver that energy, there are, unless it's a point-of-use water heater, which isn't very common, you're going to have distribution losses between the water heater and the end-use points. And that's the energy that is lost while the water is flowing, but more importantly, between hot water draws as the water in the pipes cools off. So a shower first thing in the morning, followed by a shower an hour later, that full line of water, volume of water back to the water heater needs to be dumped because it's cooled off. So there's a waste component that is, fairly significant that adds to the end use, and that the sum of those two defines the load on the water heater, the so-called recovery load. That's the amount of BTU thermal output the water heater has to provide. In providing that load, there's a combustion loss, a combustion inefficiency, and on top of that, for the standard atmospheric water heater, there's the standby loss. And that's largely represented by the pilot light, the continuously burning pilot light, as well as occasional firings, more likely in winter, where the water heater has to fire just to keep the tank at temperature. So those four components add up to what you pay for at the meter, and the numbers shown here are representative of a particular case. They will vary with load, but it does highlight the fact that only roughly 40% of what you're paying for ends up as hot water. To give you a quick overview of how Title 24 works, we'll kind of recap that. Item 1, and the hot water usage is defined, and that's the water at the tap, as we just talked about, and that's dependent upon the floor area of the house or apartment you're modeling in the compliance software. There are some constraints on that. It is capped at an upper limit, but basically there's a floor area dependency that defines how much hot water is being consumed in the house. Distribution losses are added to that, and the standard budget in Title 24 assumes a standard distribution system and associated standard losses. The standard distribution system would have would meet the prescriptive requirements in Title 24, so all 3/4 inch or larger hot water piping would be insulated. It's a non-recirculating system, and it's just kind of your standard configuration of plumbing. That defines your standard distribution losses. Item 3, the recovery load then adds those two together, and that's going to vary by climate zone and the cold water temperatures that are associated with each of the 16 climate zones in California. So the mild Southern California zones will have higher average cold water inlet temperatures, and therefore a lower recovery load because there's less heat needed to be added to that water to get it up to temperature. Conversely, climate zone 16, the mountain regions, would have a colder temperature and a higher recovery load. Item 4, the energy factor of the water heater plays into the vast majority of the compliance calculations. Most residential water heaters are rated federally, rated by the energy factor, which is a prescribed test procedure. Within Title 24, the rated energy factor is adjusted based on the recovery load, and I'll get into that in a minute. But again, the energy factor is the standard metric that we're using for describing performance. There are some larger water heaters, more common in combined space and water applications, that aren't energy factor rated and are handled a little bit differently, but that's a small fraction of compliance situations. So item 5 then, given how we've defined the standard usage for the standard distribution type, now as the builder and your compliance consultant, you define the proposed design of what you want to install in that house. Is it going to be a higher efficiency water heater, a recirculation hot water system, or so forth? And these different parameters, are accounted for in the model, and you determine a proposed budget to be compared to the standard budget defined by the standard design. This complicated equation shown here at the top, this load-dependent energy factor, LDEF, is just kind of reflects how the modeling software handles variations in load and its impact in taking the rated energy factor to a specific level appropriate for the recovery load that you're dealing with. The graph in the center of the graph shows how both gas tankless water heaters and gas storage water heaters are handled as a function of the recovery load. And again, recovery load, the sum of the BTUs that are being used and the energy loss associated with the distribution system. So for the gas storage water heater, the blue line, as the load increases, the efficiency increases, and that's because the standby energy, the pilot energy, is a fixed increment of consumption, but as you add load, you're basically increasing the effective efficiency of the system. The gas tankless water heater, the way it's handled currently in Title 24, is there's a fixed 8% reduction in the rated EF of a tankless water heater. So a 0.282 energy factor gas tankless water heater is treated, as shown in the red line, it's treated uniformly across the board. And what that 8% degradation is doing is reflecting how intermittent cycling loads affect the performance relative to how the energy factor test treats tankless water heaters. So the key takeaway here is to see that as the load in a house or apartment diminishes, and again it's a function of floor area as well as climate to the extent that affects the inlet water temperature, but as the load diminishes, the efficiency spread between a tankless water heater and a storage water heater gets more significant. So in smaller apartments, you're going to get, or smaller units, you're going to get a bigger benefit from the tankless than in larger. Here, looking at, well, two things on this graph, trying to put the compliance numbers in perspective and what the water heating budget means overall for the 16 California climate zones. On the top right of the graph with the blue bars and the blue axis on the right, I'm just trying to convey where housing starts are estimated based on California Energy Commission projections. So where building activity is statewide, and that's thousands or number of units per year by climate zone. So you know, zones 10 and 12 and 13 are the predominant for the zones with the highest construction. The bottom of the graph refers to the left axis, and there we're looking at total standard budgets for 2,100 square foot prescriptive home and total, and what fraction the water heating represents of that total compliance budget. And again, so this is a 2,100 square foot prototype home that the Commission uses in evaluating, you know, part of their Title 24 development activities. But it's kind of a generic home. But as you can see, the budgets, the green bars, the budgets vary considerably across the zones, and the water heating contribution for a standard water heater, a standard 0.60 energy factor gas storage water heater, is fairly constant. You do see some small deviations. If you look at climate zone 15 and 16, you see kind of the impact between the hot climate zone 15, so there isn't as much heat you need to add to the hot water to get it up to temperature, whereas 16 is the coldest zone, and you see a noticeable increase there. The highlight here is how significant the water heating budget is, especially in the mild zones, zones 3 through 8. In fact, there are a handful of zones here where the water heating budget is over half of the total compliance budget, and 7 being the prime example there. So that kind of indicates in each of these zones how important water heating is to overall compliance. On average, if we average these 16 zones, we're looking at about 27% of the total standard budget is water heating, but again, significant variation zone to zone. So this graph has a set of lines, and each line represents a different climate zone. And we're also looking now at 5 different cases of water heater types, and the left axis shows what percent impact that technology has on the standard water heating budget for the 2,100 square foot prototype. So if we're starting at the left standard represents the standard, so therefore there's no credit for any of the 16 cases, just shown as a reference point. If we move over one to the right, we're looking at the 0.82 gas tankless, and we see a slight variation in the credit for the tankless as a percentage of the total water heating budget, but it's roughly in the 30% range, and it varies slightly by climate zone. The next case in the middle, we're looking at a 2.4 energy factor heat pump water heater. Heat pump water heaters are fairly new to the market, and more common in other parts of the country, but we'll be seeing more of them in California. But under the current modeling rules, you see that this water heater and how the climate impacts are handled there is a variation in performance impact. The very bottom data point in that circle, kind of the purple lilac line, shows that in climate zone 16, the heat pump water heater, because of the cold climate there, is not a good compliance solution. And on the other extreme, the milder Southern California zones, show about a 10% credit. There is some spread around there with the points kind of in the -10, most of the points in the -10 to +10 range. The fourth point is just shown for reference as an electric water heater, which isn't going to be commonly installed in California due to Title 24, but it does show the performance degradation that would exist with a 0.90 electric water heater. And then the final point to the right shows what that electric water heater with a 50% solar fraction solar system would do. So even that, for this 2,100 square foot prototype, is not a good scenario. Now you can couple solar with a heat pump water heater and get different results, and this isn't to disparage solar across the board. I mean, there's certainly multifamily applications where it's very good, but it's challenging. Certainly with an electric water heater, with a heat pump water heater or gas water heater, you'd see different performance impacts. So I think Shannon has a poll that she's going to offer now.
Yeah, so just a little break to get your feedback on this slide in particular. So I'm going to prepare to launch it right now. So the question, let's see, I'll just launch. The question is, how surprised are you by the relative performance of these water heating alternatives? Please select one. Not surprised, somewhat, and very surprised. if you have a really strong opinion about this poll, you can feel free to enter that comment in the questions bar, and I'll just let you guys respond. Okay. Mark, would you like to guess what people responded?
I would say surprised.
Yeah. Here, I will share. I don't know if you can see the slides, but very few, very surprised, and a majority, or at least more folks responded somewhat surprised.
Mm-hmm.
I don't see any particular comments on that poll, so I think I can let you carry on.
Okay, thanks. So now I want to talk a little bit about some of the more recent field work that we've been involved in, and just kind of give you some interesting information on things that we've learned, and it's and there is a lot to learn in water heating. But two projects that I'm going to talk about, and the first one is an Energy Commission public interest energy research project that was administered by the Gas Technology Institute, and the title of the project, Facilitating Market Transformation to Higher Efficiency Gas-Fired Water Heating. So that was completed in 2013, and there's a link to that report at the bottom. It's a very several hundred-page report and a whole range of activities in that project. One key element of that project was Davis Energy Group, DEG, completed field monitoring at 18 homes throughout California, and we went in basically and did some detailed monitoring on the existing water heaters in these homes, and then they were retrofitted with a range of high-efficiency gas technologies. 6 of these homes were in Northern California and PGE territory, and then 6 were in Southern California gas territory, and another 6 in San Diego gas and electric. So we completed about 8 or 9 months of base case monitoring on the existing water heater, and then retrofitted the advanced water heaters in, and got some post retrofit monitoring data, roughly about 5 months of post data. So interesting to see households as, if a new technology is put in, how they respond, to that. And the primary, question or point of interest is going from a gas storage technology to a tankless system, which provides a slightly different water heating experience. Anyway, the 18 water heaters, 6 of the water heaters installed were Energy Star non-condensing storage units that are currently have been out on the market for a few years, and these are in the 0.67 to 0.7 EF energy factor range. They do offer higher efficiencies, and some are power vent. They all have electrical connections, and so they are kind of the next step up in efficiency from the mass market atmospheric water heaters that are out there. 2 condensing storage water heaters were installed. These are not energy factor related. These are rated by thermal efficiency. Again, these are more commonly going to be found in combined hydronic applications, but the project wanted to test how these perform. And then 3 non-condensing tankless water heaters, 0.82 energy factor level. That's kind of the standard efficiency level for non-condensing. And then 5 condensing tankless water heaters, and they're in the 0.92 to 0.96 energy factor range. And then 1 hybrid water heater. which basically was a technology that combines a tankless water heater with a smaller storage buffer tank, roughly a 30-gallon tank. And the concept there is that the buffer tank provides for additional capacity, and it also eliminates some of the issues that are associated with tankless, which is slight delay in getting hot water when it starts from a cold start, and also the cold water sandwich effect. So this hybrid water heater, though, is no longer on the market, but it was still tested as of 4 years ago. So some of the results now on the bottom, we're showing kind of the notation for the different individual sites, PG for PG&E, LA, and for the Los Angeles, Southern California gas sites, and SD for the San Diego sites, and then annual projected base case usage in therms for the different households that we looked at. We monitored for 8 or 9 months, so we kind of extrapolated that data to get a full year estimate, which is shown here. So what you see here, all but sites PG5, the fifth one in from the left, are gas storage water heaters, and the blue bar denoting what the energy consumed by the pilot light was for each of the houses. So PG5 with an existing tankless water heater did not have any standby, but all the others showed standby. And to us, somewhat surprising was there was a reasonable variation in how much energy the pilot light consumed on an annual basis. On average, it amounts to 40 therms just to keep the tank hot over the course of the year. Again, usage varies by climate zone here, or I'm sorry, by site here, based on household site and overall hot water use. But as you can see in site LA4, and let's see, I guess that's the best example. The pilot energy, basically the energy to keep the tank hot, was greater than what they consumed on the energy for hot water delivered to the house. So that's SD3 is kind of similar in that regard. So in mild climates, a lot of the energy goes to just keeping the tank hot. This graph is now looking at recovery load. Again, the BTUs coming out of the water heater on a daily basis, and how that varied seasonally for the 3 locations, Northern California and the 2 Southern California sites. The purple horizontal line is what the energy factor test is assuming when it rates the water heater. So that's slightly over 40,000 BTUs per day. You see in California, for the houses we tested, that was exceeded very infrequently just for January and February in Northern California. Midsummer in Southern California, you're running loads that are about a third or almost a quarter of that. So much lower, again emphasizing the standby effects. So how does all this play out on drawing conclusions? Basically, standard atmospheric and the Energy Star water heaters were found to result in about a 10% performance degradation due to these lower loads that we're seeing in California. Non-condensing gas tankless water heaters were in the 8 to 10% degradation range, and 8%, by the way, is how Title 24 currently handles tankless water heaters, so that was reassuring that we're in the right ballpark with that. Condensing gas tankless water heaters, more in the 0.92 to 0.96 energy factor range, suffered about a 15% degradation in performance, so slightly more than the tankless water heaters showed. And then the 2 condensing storage water heaters which are rated by thermal efficiency, which is more of an instantaneous measure of efficiency, basically showed about a 20% reduction compared to their thermal efficiency. So if they were rated at 90% thermal efficiency, they were operated more on an annual basis at a 70% efficiency. Some quick economic calculations now, just to give you a sense of cost effectiveness. And again, this is not looking at any incentives through utility rebate programs or CAHP or anything like that, but just keeping that to the side. So if we look at Energy Star, TWH is tankless, CTWH condensing tankless, and condensing storage, we have these cost estimates in new construction and in retrofit. And again, especially in retrofit, there's going to be variability in cost with site situations and so forth. But if we apply those costs to the savings we were projecting based on our monitoring, we can look at simple paybacks. Again, no rebates, and assuming $1.30 per therm for natural gas. We have two sets of groupings of payback bars here. On the left is for new construction, on the right is for retrofit, and then 3 levels of hot water load: high use, typical California use, and low use being the purple bars. And again, the higher the usage, the better the economics are going to be, the sooner you're going to pay back the initial investment. So on a new construction basis, we're seeing that the tankless and condensing tankless show, paybacks in the under 10 to slightly over 10-year range, depending on usage level, while the storage technologies are longer, although the condensing storage on the high use case, the red bar, does look comparable to the tankless technology. If we look in the retrofit grouping to the right, with the higher incremental costs that we were looking at, we do see longer paybacks, significantly longer paybacks. Again, no incentives here, but retrofit is more challenging on the cost effectiveness case. Now I want to talk briefly about some work that's ongoing with PG&E and Reading Electric, where we monitored 2 heat pump water heaters located indoors in the Reading service territory. I'm going to go through this a little quicker since I want to leave enough time for the rest of the presentation here. Why heat pump water heaters? On a national basis, it's a big part of, or a big opportunity, as there's a lot of electric water heaters throughout the country, much less so in California. But in California, there is interest in heat pump water heaters as a component of an all-electric zero net energy strategy. So we expect to see more of these coming. The research helps to understand how these systems perform in California, how they're sensitive to loads and load patterns, and how they control sequences, internal to the systems affect performance. Again, there's a lot of field work in other parts of the country, but little data so far. On the con side, if we say, what is holding heat pump water heaters back, we've already talked about the Title 24 assumptions, and primarily how TDV values electricity relative to gas. That currently is a fairly significant punitive handling of heat pump water heaters in that regard. And then on the ratepayer side, or the homeowner side, California has, as we know, fairly expensive electricity, 6th most expensive out of all the states in the U.S., but natural gas is relatively cheap. So with the the widespread availability of natural gas in California, it is going to be challenging for heat pump water heaters, depending on what the rates are. Some municipals definitely have cheaper electric rates, but so that is a challenge for heat pump water heaters. I guess Shannon, you had another poll here.
Yes, thanks for the reminder. Let me get that started. Okay, so I'm going to launch it now. So the question is, if you were to build a zero net energy home, would you consider a heat pump water heater in your all-electric package? So responses, definitely, definitely not, or I'm not sure yet, I'd like to learn more. And a lot of answers coming in. Okay, I'm going to close the poll, and as before, Mark, I invite you to guess what people responded.
Okay, and I'm going to guess. I'm going to play middle of the road and say I'm not sure.
Yeah, we had a lot of. I'll share the responses now. I'm not sure yet. I'd like to learn more. It's 30%, and then definitely 53%. I guess in crafting this question, Mark, what other options would there be besides the heat pump water heater for an all-electric package?
Well, that if you're going to go all electric, and which is something, well, in UC Davis, the West Village project, which is going a zero net energy community, they made the decision to go all electric in student apartments, and they did go with heat pump water heaters. So I think that's the fundamental question. If you are going to go all electric, and there are people interested in getting away from natural gas, and there are costs associated with bringing that service in. So if you're going to go that route, I think heat pump water heater is your choice.
Yep. Great. So I'll close this poll, and I'll let you continue.
Okay. So to summarize the findings of this, the monitoring, kind of a similar detailed monitoring as we did in the gas study, began last May and is continuing until this May. In the summer, we found at these two sites, we found good efficiencies, COP, coefficient of performance, 2.6 to 2.85, which exceeded the rated energy factor of the unit. And one would expect that because the temperatures are more favorable for the heat pump to operate. Electric resistance, which is the backup stage for these units, was relatively small during the summer, 4% at one site and 13% at another. And these units were both located indoors, which was one of the testing goals of this project. And we tried to quantify the cooling benefit of having that unit indoors. And it's basically in the 120 to 135 kilowatt hour per year for these two homes, one of which was a pretty high cooling user. As we get into winter monitoring, of course, we're seeing different things. Hot water loads are much higher, as we saw that in the comparison of the monthly loads on the gas side. So they're 2 to 2.3 times higher thermal load on the water heater in the winter months to date than we saw in the summer. And the efficiency of the heat pump is lower as we're both getting colder inlet air to the heat pump, which lowers the efficiency, and the water is colder, which contributes to more resistance heat operation, which is now in the 12 to 19% of total heat pump water heater consumption for the two sites. So winter COPs are in the 2.05 to 2.16 range, so lower, but still, promising, as we look for an annual field efficiency of these units by the end of the year. So performance, is looking pretty good. We want to get away from resistance heat operation to the extent you can. So to wrap up here, key points. The water heating loads in California are significant as a total component of the residential gas consumption and do play a big part in Title 24 compliance, especially in the mild zone. So something to take a good look at overall, but specifically there. The observed hot water loads in California are much lower, 30 to 35% lower on an annual basis than what's reflected in the energy factor test procedure. And there is a new test procedure coming out April of this year, which is more involved and looks at products differently. I don't want to get into that too much right now. Important thing to think about in the standby effects of storage water heaters are significant, and especially as loads diminish. All these houses we were testing in, were 5 to 40 years old. So as we look at newer houses with more efficient hot water appliances and low flow fixtures, we can only expect that hot water loads are going to go down. So standby effects of the storage water heater are going to become more significant. Efficient options that we studied, especially the tankless, do save energy, but the first costs are higher, and so that's why you have to look at the programs like CAHP and other utility incentives to see how that factors in. Retrofit is especially challenging. Heat pump water heaters, we're finding certainly an efficient alternative versus electric as we look at the COPs over 2 versus electric water heater at 0.9. But California utility rates and the TDV is working against you there, and where we do need to understand better how the controls work and how we can make these systems run even more efficiently as how they respond to changes in tank temperature. And the final point is kind of an ongoing effort, and probably the hardest part of all the hot water research is to understand how distribution systems, how they perform different distribution system types and what the impact is on total energy consumption. So that concludes my presentation.
Thank you, Mark. And our next section is a brief section. We actually invited one of the CAHP plan review managers, Deborah Heyman, who some of you may know, to present on some incentive analysis of some of the water heating systems that Mark discussed in his presentation. So I'll let Deborah take us into those results.
Hi, everyone. So our team wanted to give you an idea of how tankless and heat pump water heaters currently affect CAHP scores and incentives. So I'm going to go over that. Next slide, please. Thanks. So to do this, we took 3 typical single-family energy models and compared the CAHP scores when we put in a typical tank storage DHW system, a tankless system, and a heat pump system for all PG&E climate zones. Next slide, please. So for our analysis of the tankless water systems, we compared the baseline DHW system with, going back. We used a 0.65 EF storage tank DHW as our baseline because it's more typical for CAHP homes than a standard 0.575 EF system, and we felt that that would give you a more accurate representation of the savings realized with tankless systems. So for our analysis of the impact of tankless systems, we compared the baseline DHW system with a 0.82 EF tankless DHW system and a 0.93 EF tankless DHW system. Overall, we found that installing tankless systems resulted in a CAHP point benefit of 2 to 4 points, which resulted in $200 to $800 in additional CAHP incentives per lot. And we saw the greatest energy savings and greatest CAHP point benefits in climate zones 2 through 5 and 12. So there you go. So here's a table of the CAHP point benefits by climate zone for your reference. We'll make these slides available to you after the webinar, so you can refer to these tables later. And next slide, please. So as Mark mentioned earlier in the presentation, assessing the benefits of heat pump water heaters is difficult at the moment. If gas is available on site, the compliance software will compare the heat pump water heater to a 0.60 EF gas storage tank water heater. And if gas is not available on the site, the compliance software will compare the heat pump water heater to a 0.95 EF electric resistance DHW system with a 50% solar fraction. So despite that, we still wanted to give you an idea of how heat pump water heaters affect CAHP scores currently. So we compared a 2.3 EF and a 2.7 EF heat pump water heater to a baseline 0.65 EF storage water heater. Next slide. Thanks. Overall, we found that the 2013 standards were pretty tough on heat pump water heaters. We found that if we checked that natural gas was available on site in the compliance software, the heat pump water heaters hurt CAHP scores by 1 to 11 points. This impact was minor in climate zones 11 and 13, while climate zones 4, 5, and 16 saw the most negative effects. So if natural gas wasn't available on site, the heat pump water heaters did improve CAHP scores in most climate zones. So it's good news there. And we still need to investigate further to understand heat pump water heater performance in 2013 standards, so we can identify ways to increase the savings seen from heat pump water heater systems in the compliance software. Because as Mark went over earlier in the presentation, heat pump water heaters are a great alternative and they can result in a lot of energy savings, so we just need to work to find a way for the software to recognize that.
Thank you, Deborah. So now is the time when we can take questions, and it's 12:53. And for those of you who are available, if we have lots of questions, we can stay on a little bit after. So we have a few, actually one for Mark and one for Deborah. So I'll start with the question for Mark, tracking back. So I'm not sure if you researched this in your analysis, so you can choose to answer this question off the air some other time, but it's a question in particular in relevance to greenhouse gas emissions. So here's the question. My analysis has shown that with the current electric grid mix, that the highest energy factor natural gas water heater, so 0.95, has 65% higher net greenhouse gas emissions than the highest energy factor 0.31 heat pump water heater. Can you please comment on this?
No, not off the top of my head, but I don't dispute those findings. I mean, we did look at that a few years ago in a study looking at greenhouse gas impacts of different technology types, and it did find something like that. So that certainly sounds reasonable.
Thank you. Yeah, I think the intent of that question maybe is just to raise awareness for the fact that there may be other motivations besides return of investment or just being zero net energy, considering the greenhouse gas side. So.
Right. Good point.
Yeah. Thanks for that question, Michael. So this is a question for Deborah. I'm wondering, did you develop those tables, the climate zone analysis tables for the heat pump water heater analysis?
Yes.
So we maybe can, Andy is asking if we can show the results from that analysis, and I guess we can certainly include it in the slide deck when we follow up. So stay tuned for that. Okay. I'm just looking at the next questions. 1 second. So Deborah, this is another question for you on the CAHP incentive. May also take some further investigation off the air. How does using a condensing storage water heater greater than 750,000 BTU capacity affect the program incentive? Was that something that you looked into at all?
That is not something that, I'm sorry?
Oh, the BTU was 75,000.
Yeah, for this purpose, we mostly looked at small storage tank water heaters. So we didn't get to that size water heaters, so we haven't yet run the models to see how that would affect the CAHP scores.
And if there was a lot of interest in seeing further analysis on a specific water heating system, we could consider doing that analysis as well. So if any of you have feedback for us on that topic, feel free to send that in. Okay. So Mark, this is a question for you on, it's kind of a contrast between 2008 and 2013 code. So in the 2008 code, condensing storage water heaters can be a slight penalty or credit depending on standby losses. Can you address how this is impacted in the 2013 code?
So my understanding is that there was an error in how standby loss was handled for large storage water heaters. The way the calculation was applied, and to my knowledge, that has been corrected. But, I can verify that. Basically, the standby loss impact, I believe, was overestimated previously.
Okay, I'm looking to see. I actually don't see any more questions right now, so if you have one, feel free to type it in. Otherwise, we'll go on to the next slide in a minute. And you can always follow up with us off the air if you have a different question to ask. Okay. So here's our contact information for California multifamily new homes. You can reach us at info@cmfnh.com. And for California Advanced Homes Program, it's cap@trcsolutions.com. And you see here the names of the folks that run both programs. And following this presentation, you'll see a survey launch. And we're really excited to be producing these webinars for you and to have all of you join in. And so the intent of this survey is to really get your feedback on what you valued about the presentation, and also get your, I guess, solicit interest in specific topics. So we'd like to hear what you would be interested in as far as webinar topics for this year and possibly next year. So I think that brings us to the end of our presentation. Please take the survey. We really value your feedback, and have a great rest of your day. Thanks, everyone.